Hello, my name is Gabriel and welcome to the City Structures channel. In this video, I want us to look at how to use claddings in the Autodesk robot software. This is a useful feature, especially when it comes to load transfer. If you're new to the channel, here we talk about structural analysis and design software. If this interests you, then don't hesitate to subscribe to the channel. So let's get to it. Claddings are essentially load transfer members. They are used to generate bar loads from planar objects such as walls and floors, and also loads from winds and snow. In other words, they can be used to represent walls, slabs, and other types of coverings. They don't have any self-weight. Therefore, if you have a structure that only consists of frame elements, or you do not wish to design any of the planar elements in the or within the software, then you can use claddings as a surface for receiving loads. So they are modeled in the same way you will model a slab or a wall. So I'm just going to demonstrate it, fill this frame structure with claddings. So go to geometry, click on claddings. Now in this window, we just have the first thing. I'm going to set up the load distribution method. Now there are three ways, or perhaps just two ways. It can be one way or two-way means of distribution. So for the one way, it's going to be distributed in one direction. For the two-way, it's going to take two directions. These directions are in respect to the orientation of the local axis of the panel. Let's just begin by perhaps demonstrating with a simple staircase. The staircase, I'm going to begin with the wastes. So I'm going to distribute them in one way Y. Let me just draw them. Pick the rectangle option. This is going to go down like that. I'm just going to draw the other waist to the top. Then I'm going to change for the landing. I want it to be distributed in X, so that I select it here and here like that. And as you can see, there's just a marker here showing you how the loads are being distributed. So this green marker showing you that the loads are distributed to the top and the bottom of the Y orientation. This one is going to represent it being distributed in these directions. So perhaps I can change this because it might not be the case. There's a beam here and there's a beam here. So I'd wish for it to be transferred this way and this way. So I can decide to just change that. Just pick in the Y direction. So it's supposed to go in this direction. So if I apply it, as you can see, there's a green line here. Then let's continue. Just close this. So for the remaining one is a large floor at the top here, and also another large floor at the bottom. I'm going to pick two-way, because there are several beams I want it to be transferring the loads to. So the staircase here, go to the first story. So I'm going to just draw it away from that staircase opening, like that. Then as you can see, the marker is blue and green, showing us that it's two-way, or rather the distribution is in two ways. Then I can go to the base level. I need to cover the whole base, so I can pick a rectangle in this case, something of that sort. Then I close it. Just go back to the original view. So as you can see, you just have a covering here for the panels. Now let's perhaps add covering for walls. Then you can perhaps add some wind loads on it. So let me just place it here and here and here, also here, and then lastly there. So as you can see, I've placed a wall. I can also even add perhaps an opening, just represent perhaps a window or something of the sort. So let me just take a rectangle, let's perhaps say a window of height 1.8. Just take something, not sure about the window heights, not really an expert on windows, and let me just place it somewhere there, then close it, something of that sort. And perhaps I can also add other panels to just cover the remaining places. Like that. Perhaps just on this point here alone. Don't want to cover it so that we cannot see the staircase. Yeah, that's it. Then now let's add the loads so that we can just demonstrate. I'm going to perhaps just apply one extra load. Or rather, let me add also for wind, just to make it a bit comprehensive, like that. Then let's define it. Of course, for the winds are going to be applied on the walls, rather on the claddings representing the walls. So we're going to look at the direction of the global axis here. So as you can see, for the wall, this wall, the wind is going to be coming from this direction. So it's going to be negative y. So we're going to select here negative, let's take perhaps 1.5, something of that sort. Then let me just apply it, select this and apply it there. Then I also want here, but now I want it to be on the other side. So I'm going to select this, just type 1.5, add it, close this, or rather clear it, select this one, and apply it. So as you can see, it's entering it. Also this one. Then I can also go to this other side, just apply another one. So as you can see, this one is going in the x direction. So I want it to be in the negative x. So minus 1.5. Then keep this at 0. Then I'm going to just select this one, apply it. So we have all of that applied. Then let me just add the dead load, or rather the extra load, to the other claddings. Perhaps let's just use a simple dead load of a simple slab. Let's take around minus 3.6 for example, and keep everything as 0. Then we're just going to select the panels we need. So I need the staircase panels. Select it, then press Ctrl. Go to select these panels here. Apply it to them. And this last panel here, panel 47. Also apply like that. I think we've applied all the loads. So next up we can just define a combination to help us analyze it better, like that. Then apply. Then let's just calculate. Once you're done, as you can see, there's a pattern here which is forming on the claddings. It just shows us how the loads have been distributed to the bar members. As you can see here, this column here is receiving loads in this manner. Then also you can see there's a different pattern when it comes to the openings here compared to these other sides. If you go to the top, you can see there's a different way in which the patterns are being represented. So for example, this beam is receiving this pattern and this pattern from the panels, or rather the claddings. If you go to the staircase, they're receiving, as you can see, they're distributing the loads. So this, what do you call it, the landing is sending loads to this beam here. There's another beam on this side. This is an easy way to just transfer loads without having to define the panel elements. So let's perhaps try and have a look at the results and see how they fare on. Just going to pick a ULS combination that we created. So let me just see how they look like. And then let me go to parameters. Just define how they're going to be represented. Then we're on the XZ axis, something of this kind. Then I can also perhaps let me just segregate some of the elements. Perhaps let me select this beam over here. Then let me go to detail analysis. Just want to see it much better. So this is how the beam has received all the loads from the claddings. Also check out the shear like that. So the cladding is essentially an easier way to just define loads and perhaps provide a means of transferring the loads to the bar elements, especially in the case where you only wish to design the bar elements themselves. If you found this video useful, you can like and subscribe to the channel. See you in the next video.